Hello class, welcome to another video for this course. In this video, we are going to study the second section of chapter 5, section 5.2, angles. Okay, so you know that in chapter 5, the goal is to introduce trigonometric function, which is based on circles, and we already studied circles. But another thing that is very relevant to this study, is the base of trig function is the concept of angle. I know perhaps most of you already familiar with concept of angle, but we want to overview angle one more time, talk about it in details, talks about the measure, and also introduce some new measures and things about angle as well. So let's, to make sure that all of us have the same definition of what is the angle, how we define it, how to measure it, let's make a ground rule that when we, first of all, when we measure an angle, it's a measurement between two intersecting lines. So for example, in this picture, in this graph, you can see that you have two lines and these two lines intersect at a point. Now, this intersection of these two segments of line creates an angle. So between these two, one of them is the initial side, the other one is the terminal side. And that depends on our agreement. We agree that when we talk about angles, the rotation is counterclockwise. So perhaps I draw it here. So look, suppose this is, and always when you talk about angle, always start from ground. So draw a horizontal line, and suppose this is your ground. In your textbook, it's called it initial side. So suppose this is always start with a flat ground. So that's going to be your initial side. And then you are moving counterclockwise. So suppose you start from here and then you go up and you stop here, right? So you stop at this point. So the terminal point or terminal line, or in other words, based on your textbook, terminal side is gonna be right here. So pay attention that we always, the standard, when we talk about angles, the standard direction is moving this direction, moving not clockwise, counterclockwise. And we always start from the ground. So you suppose this is always ground. If I tell you, for example, find me that angle, you start from the ground and then you go, you move counterclockwise until you hit that specific angle. So this is an angle, okay? And then for measuring angle, actually we have two measurements that we are going to introduce. The first one is degree. I'm sure you are familiar with the degree. Degree is a measurement of angle. How does it work? A full rotation. So if you have a full rotation around the circle, so in other words, suppose this is your ground, right? And you start and you go for a full rotation. Okay, so you move counterclockwise and you go for a full rotation. Or in other words, it's like you are going around the circle for one round. That's gonna be 360 degree. Okay. So the base of our measurements in degree is that one full rotation around the circle gives us 360 degree. So if you want to know what is 1 degree, you perhaps divide it into 360 to know that one side, where is the 1 degree is that. And and in terms of notation, we use either we use the word degree. So we say, so in terms of notation, suppose I want to show that this is a full rotation, 360, either we write the word degree, so we say degree. So either we say 360 degree, or we put a circle, empty circle, empty ball on top of the 360, on top of the number. To we use this symbol to denote the measure of degree. And a standard position is that, so when measuring angles on a circle, we measure angles in the standard position. We start from the positive horizontal axis and we go counter-clockwise rotation. That's important. So for example, give the degree measure of the angle shown on the circle. So this is the circle, right? Let me, I want to show you a circle. So okay, so look, suppose this is a circle, right? I'm gonna draw the same picture as it is in your textbook. This is example 1 in the textbook. Example 1. So in example 1, it shows us this angle. And the question is, what's the question? The question is, give the degree measure of the angle shown on the circle. So look, how can we know what angle does this represent? This. What is the, for example, in degree, how many degree is this angle? Okay, so we can go by this argument that a full rotation around circle is gonna give me how much? 360, right? So that means if we start from here and we do a full rotation, I can either start here or start here. Maybe I start from inside. Suppose I start from here and then I go a full rotation around the around the circle, which means that I go back to my initial place. This is gonna be 360 degree. Now, what is this indicated degree? Look, it starts from the same initial place, but it goes counterclockwise and it stops right here. So look, so it's like it rotates. It does rotate around the circle, but it stops for a quarter of the way. So it's like, imagine you divide this circle into 4 pieces. So it's like this angle only moves around this circle for a quarter of it, you see? It's only a quarter of the angle. So for that reason, this is gonna be 360 divided by 4, because this angle stops at represent just a quarter of 360, which is gonna give me 90 degree. So this is 90 degree. Okay, the next question is, let's show an angle of 30. So if I want to find, if I want to draw, for example, this is the circle. Suppose the circle is given. So this is example 2, and suppose this is the circle. The question is that draw or show angle of 30 degree. 30 degree. Okay, so look. So far we know that a full rotation gives us 360. We also in the previous example saw that a quarter gives us degree of 90, right? Because the full rotation is 360. You divide it by 4, you get 90 degree over here. This is, so this whole thing, this represents 90 degree. So can I know for 30, I have to, I know that I have to start from here, right? I should start from here, but how much should I go? How much should I rotate around this circle? So what is the relationship between 90 and 30? 90 is 3 times bigger than 30, right? In other words, if you divide 90 by 3, you get 30. So if this quarter, if this quarter, the first quarter of this circle contains 90 degree, so if I divide it into 3 pieces, so I'm going to divide it into 3 equal pieces. So suppose this is 1/3 of this quarter, and this is another third, right? Suppose they are equal. Then I can get 30. Look, I can start from here and go up and stand. Oops, sorry. I can start from here and go up, go counterclockwise, and stand here. This is gonna be, this angle is gonna be 30 degree. This angle is gonna be 30 degree. Again, how did I come up with 30? For all of the angles, when you want to draw them, you should start from the horizontal line, from the ground, and move counterclockwise. But where should I stop? We should stop at a place that is exactly 1/3 of 90, 1/3 of so maybe I write it here as well. So if you divide 90 by 3, you get 30 degree, right? So it's like, this is quarter, I divided it into 3 equal pieces. So this piece measures 30, a quarter of 90, which is 30. By the way, when in terms of notation, when we talk about angle, we often use Greek letter. So perhaps it's good to refresh our mind about what does represent what. So this notation is theta. So this is called theta. This is phi, alpha, beta, and gamma. Oftentimes, when we want to say, okay, for example, the angle is 30 degree, we would say theta equal you can also use X, Y, and Z, Latin alphabet, but we often, in textbook, we use Greek letter to denote angles. Another concept that we need to review about angle is coterminal angles. So what is a coterminal angle? So after you complete a full rotation based on angle, 2 angles are coterminal if they terminate in the same position. So for example, look at here. Suppose we start from here and go up to here. Suppose this is an angle, okay? So this is gonna be, this is an angle, right? Okay. Now, suppose we do a full rotation. So there is another angle. So we start from the ground and then we do a full rotation. And then when we hit the ground again, we go up and we stand at the same terminal side or same place as the other angle. So these two are called, these two, maybe I show this by theta, maybe I, for example, let me name this theta. What's happening? Suppose this is theta and the other one is beta. Then theta and beta are the same. So this is so basically, it all depends on where the angle stops? When does it terminate? So maybe you go and stop somewhere, or you go a full rotation and go up and then stop at the same place. They are called coterminal angles. So I'm going to show you an example. Okay, so let's see an example of coterminal angles. Let's look at example 3. It says find an angle theta that is coterminal with 800 degree, where theta is between 0 and 360 degree. Okay, so let's do example 3. So we are looking for theta. We use theta to denote angle. So find theta such that it's that is coterminal. It has the same terminal place with 800. With 800 degree. Such that theta is between 0 and 360 degree. Okay, so look, let me draw a circle or something to denote, to help me for the rotation. So 800. So look, when you go one full rotation, let's start from here, rotate around this circle counterclockwise. This is going to give me 360, right? So one rotation is 360. Let's go another, continue this, go another rotation. So now I rotated this circle for 2 times. So I made 2 full rotation. So 2 360, right? So I rotated the circle for 2 times. That means the current angle is 360 multiplied by 2, which is 720. So up to here is 720, right? Okay, how much else is left to get to 800? To 800, let's see, 800 minus 720, 80. So that means if I continue this rotation for another 80 degree, so let's go continue and stop here. Suppose this is 80, okay? Suppose this is 80, right? Then that's 800. So that's 800 degree. How did I draw the 800? So we first started rotating around the circle. One full circle gives me 360. We continued for another one. 2 complete rotation gives us 720. And then we went further for 80 degree, which because 720, or in another words, look, you can write it as 3. We did 1 360, another 360, and then we did 80. So in this way, we reached at 800. So this is 1 full rotation, second full rotation, and then plus going another 80 degree gave us the terminal place for 800 degree. Okay, so now I'm sorry, what degree also stand at the same place? So look, this degree, this one. So if you start from here and just go and stop right here, then this degree, this angle also have the same terminal place. It stop at the same place, which is how much? 80. So 80 also has the same terminal point. So in this way, you can say 80. So you can say 80 and 80 degree and 800 degree are coterminal angles. Why? Because both of them stop, they have the same terminal side. So the angle is 80 degree, which is coterminal with 800. Now, okay, so far, every time in any example that you saw when we talked about angle, whether it's 80 degree or 800 degree or 360 or 30 degree, as you can see, so far we are just talking about we are using positive numbers, right? So we say positive 30, positive. So what about negative? For example, what does it mean? What does it mean to say angle of negative 45 degree? So for angle values, so if you have an angle, let me put it here. If you have an angle that is negative, it's a negative value. So what does that represent? The way it represents is that, suppose again, this is your ground set, and our so far the standard was that, so you start at the ground and then you rotate around the circle counterclockwise. Now, if the angle is negative, then you start at ground, but you move clockwise. That's the difference. So that's the difference. So for example, in this question says, show the angle of negative 45. Okay, negative 45. So if I'm gonna show negative 45, the question says, show negative 45 degree angle, right? Okay, so I'm gonna draw you can draw the circle or do it without the circle. I'm gonna draw the circle. So we start from here, we start from the ground, right? But because it is negative, I have to go the other direction, the opposite direction. I have to move clockwise. Now, how much for 45 degree? 45 is half of 90. So that means half of this, up to half of the quarter, right? Because each quarter, we saw that each quarter is 90, right? You saw that, for example, because the whole circle is 360, the whole rotation is 360, you divide it by 4, it gives you 90 degree. So each quarter is 90 degree. Now, if you divide the 90 by 2, you get the 45 degree. So that means divide the quarter in half, that's gonna give you half of 90. So this gives me 45 degree. Now, because from the ground, I moved counterclockwise in the opposite direction, that represents the negative 45. So if you say, where is the positive 45? Positive 45 is, look, so you go, again, 45 is half of the quarter. So you start from the ground, but you go clockwise, you see, for the half of the quarter. And this is gonna be 45 degree. So what is the difference between the green angle and the orange angle? Green angle represent positive 45 degree. It's moving in the standard, in what we agreed for the direction. But the orange angle is the negative 45. It moves counterclockwise in the opposite direction. Okay, oh, and one more thing, show the angle negative 45 on this circle, and find a positive alpha or angle that is coterminal with this. Okay, so I'm going to show you in the next picture. Now it says the question had two parts. The first part was to show the negative 45 degree. The second part says find a positive angle that is coterminal, with negative 54 degree. Okay. So this is negative 40, look, this is negative 45 degree, right? Now, the question is find a positive angle. So because it says positive, that means I have to start from the ground and move counterclockwise. Okay, where should I stop? We want them to be coterminal, meaning that they should have same stop side, same terminal. So I should stop here, right? Because coterminal means they should have same terminal side. Okay, so this blue one represents a positive angle that is coterminal with negative 45. Now, what is the value of this angle? Let's see. So it's not a full rotation, but you can say it from a full rotation, right? Because if you go around the circle for full, if you go back 45 degree, 45 is what is missing from the full rotation. So that means if you subtract 45 from 360, you get the value, which is 360 minus 45, 315. So that is 315 degree. So this part, okay, this part is 315, okay? This angle, the blue one, is 315. And this orange one is 45 degree. And as you can see, the sum is 360, okay? I encourage you guys to look at this diagram and try to, play with it, because it's very, very helpful to be familiar with the places of these degrees. I'm gonna, I know this seems a lot, but I'm gonna play some of them that are key. So let me draw some that are key, and you definitely, it is definitely worth to know where these angle, where is the place of these angles. Maybe I should show it here. Look, so suppose this is a circle. Okay, so ground is 0, okay? So always, because look, if you imagine you are in a flat ground, right? And you're not moving anywhere, so there is no angle over here. So that's 0, okay? That is 0. So here is 0. That's our origin. The ground is 0. And then we said that a full rotation, which means if you go around the circle one full rotation, which means you go back to the same place, that's going to be 360 degree. So in other words, 0 and 360 are coterminal, because if you imagine you are here, you go a full rotation, you rotate around this circle for one full rotation, you come back to the place that you started. So you are in the same place, but you did a full rotation, which is equivalent to 360. Okay, so halfway through, when you do the full rotation, maybe I go back here, halfway through. So when you start and you will stop halfway, so that means 360 divided by 2, right? So if you instead stop right here, so that is 360 divided by 2, which is 180. It's good to remember that this is gonna be 180, okay? This is gonna be 180. Now, halfway through 180 is gonna be 180 divided by 2 is gonna give us 90. So this is 90, you see. This is 180. And this one is, so you see, each quarter is 90 degree. So 180 plus 90. 180 plus, so up to here is 180, and you go 1/4, 90. So 180 plus 90 gives you 270. So definitely know the place of 0. So in general, when you have, so in general, if you draw a circle, you should know that this always represent angle 0 degree. This is 90 degree. This is 180 degree. This is 270 degree. Now you are here after a full rotation, that's 60 degree. And you can keep doing this, right? But definitely you need to know that the place for 0, for 90, for 180, and for 270 degree. Now, where is 45? 45 is right in the middle, right? Here. This is gonna be 45 degree because it's 90 divided by 2. So it's just half of the first quarter. What else? 30 and 60. So 30 is less than 45. So this is gonna be 30 and 60 is gonna be right here. 60 degrees is gonna be right here. Right? So at least know some of them, okay? At least even if you, it's good to know all of them, but at least know the place of some of them. It's gonna help you when you're dealing with questions. Okay, now let's talk about another measure. So far, when we talked about the angles, we said degree, like 30 degree. Like in this picture, I said 0 degree, 90 degree, 45 degree. But there is another measure that we need to learn. So to introduce that measure, let's talk about arc length. Arc length is the length of an arc along side of the circle. Let's say the circle has a radius that correspond to a specific angle. It is the portion of the circumference between the initial and terminal side. So in other words, what is arc length? It's like, look at the circumference of the circle, the portion that is between the initial side and the terminal side of angle. In this picture, it's the red curve. You see, there is a red segment on this circle. So theta is the angle. So this is a circle, radius is r, and theta is the given angle. Now, the arc length corresponding to this theta, determined by this theta, is the part of the circle that is between the initial side and the terminal side. Okay, what do you need to know about arc length? Okay, so we want to drive 2 pi. Okay, so if you have a circle in general, so in general, when you have a circle, we know that if the circle has radius r, suppose radius is r, the area is 2 pi r. Do you remember the area of circle? The circumference of circle is 2 pi times r, in which r is the radius of the circle. The circumference of any circle is 2 pi times radius, right? Okay, so and the idea is that so I want to drive something, and I'm going to use drive it by using these the example here. So here we have a circle of radius 2 and circle of radius 3. Okay, so in this picture we have a circle of radius 2. So this is radius 2, and then we have a bigger circle of radius 3. Okay, and then we are looking at 40. So by the way, the circumference of the smaller circle, the inner circle, maybe I call it inner circle. Inner circle, what is the circumference? Is 2 pi r. R is 2, so it's 4 pi. The outer circle area is 2 pi r, r is 3, so it's going to be 6 pi. Okay, so those are the area of each circle. And then look at degree 45, for example. Okay, so this is degree 45, right? This is 45 degree. So the arc length, look, the arc length in this circle is this portion, because what is the arc length? It's the part of the circle, it's the portion of circle that is between the initial side and the terminal side. And then in the other circle, the arc length is this portion, the portion of the circle that is between the initial side and terminal side. Okay. So the idea is that if you take the ratio of each one, so each one correspond to 1/8 of the full circumference. Is that clear? Because look, you have so each one of, so you have the full circle, and then 45 is half of 90, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 1/8. So the point is that I mean this part. This is, maybe put it here. This is 1/8 of circumference, right? Of this area, because the whole thing gives me the circumference, and because this is 45 degree, so it's half of the quarter, so it's going to be 1/8. So what is the circumference here? It's 1/8 of this one is 6 pi. What about this one? This is 1/8 of 4 pi. because the bigger circle has the area of 6 pi, the smaller circle has the area of 4 pi, right? So that's gonna give us, this is gonna give me pi over 2, and this is gonna give me 3 pi over 4 if you simplify them, right? This and this. Okay. So although they have this arc length are different. So the arc length for the smaller circle is pi over 2, and the value of the arc length for the bigger circle is 3 pi over 4. So they are different. But the ratio of this arc length divided by the radius are the same. So for example, in the smaller circle, if you divide, what is the arc length is pi over 2. What is the radius? So what I'm doing is that I am dividing the arc length by radius. What is the arc length is pi over 2. What is the radius? It's 2. So it's gonna give me pi over 4. What's happening in the bigger circle? In the bigger circle, again, we are dividing the arc length by radius. The arc length is 3 pi over 4. Radius is 3. So it's gonna be pi over 4. So you see, they are same. So, and you end up with the same thing if you even go look at other circles. So I'm gonna show you what's happening here. Look, even if you draw other circles, for example, a circle of, for example, a circle of radius 4. So if you look at a circle with radius 4, and then look at the this ratio, that is what ratio I'm talking about? I'm talking about the ratio of arc length for 45 degree, arc length determined by 45 degrees. So in this, the arc length in this circle is gonna be this green portion divided by radius. Okay. Again, you see that this ratio is gonna be pi over 4. If you calculate that, you will see that. And if you keep doing this, look at a circle with radius 5. Look at a circle with radius 10. So it doesn't matter what is the radius. You can enlarge or enlarge these circles as much as you want, as long as you are fixing the angle, which is 45 degrees. This ratio is gonna be always same. So the observation here is that for 45 degrees, so this is the angle, right? What is the angle? The angle that is fixed here is 45 degrees, right? No matter of the circle, no matter of the size of the circle, whether it's a radius 2 or 3 or 5 or 10 or 50 or 1,000, this ratio is always same. The ratio of arc length divided by radius is always same, and it's always the same value of pi over 4. So for that reason, we can also represent the angle of 45 degrees with pi over 4. So that's an alternative way to represent and work with angles. So, and also you see that in your textbook, it says the ratio is the same regardless of the radius of the circle. It only depends on the angle. So the only factor that can change the value of this ratio is angle. So in other words, each angle uniquely determines a specific ratio, a ratio of arc length and radius. So here we have a function, right? So this property allows us to define a second measure for angle based on arc length, which we call it radian. So the radian measure of an angle is the ratio of arc length of the circular by the angle to the radius of the circle. So exactly what I calculated here. So you can, so in other words, when you talk about this angle, when you are talking about this angle, in terms of degree, you can say it's 45 degrees. In terms of radian, you can say, so this is called radian. You can say it's in radian, it's pi over 4. So, and this is the radian measure. Radian measure is S over R. What is S? S is that arc length. What is R? R is radius. We find that ratio, and that gives us the measurement in radian. And it's unitless measure because arc length and radius, they don't have measure. So it's just, so we just put radian, or you may even do not put radian, because as long as it has the pi, it denotes that it is in radian. So for example, let's practice this a little. So for example, when you do for example, what is the measurement for 360? Okay, so 360 is a full rotation, right? You start from here, you end here, and that's 360 degree. So the question is, okay, you have 360 degree. The angle is represented in degree. What is this in radian? Now say it in terms of radian. Okay, so what is the corresponding arc length here? The corresponding arc length is the entire, because it's a full rotation, right? Because it is full rotation, so we start from here, and then the terminal place is the same as the initial place. So it's a full rotation, right? So when you want to find the arc length divided by radius, the arc length is the full circle, which is 2 pi r, the circumference, the length of the circle, the length of the entire circle is circumference, 2 pi r, divided by r. R is radius. R stands for radius. Now you can cross r's, so you stay with 2 pi. So 360 is 2 pi. So we denote this either by 360 degree or by 2 pi. So one rotation, so pay attention, one full rotation is equivalent to 360 degree or 2 pi radians. So I think we can drive the rest. Half of rotation is half of 360 degree. So it's going to be 180 degree. It's half of 2 pi. So it's going to be pi. 1/4 rotation is 1/4 of 360. So it's 90. Or 1/4 of 2 pi. So it's pi over 2. So if I want to just put it in the circle, look, I told you it's good idea that you keep in mind that this is 0 degree, this is 90 degree, this is 180 degree, this is 270 degree, and then after a full rotation, you have 360 degree. Now, let's represent them as radians. So one full rotation, 360, we just saw that it's 2 pi. Half of it, so it's half of 2 pi, so it's gonna be pi, right? 1/4 of it is gonna be, or 90 is half of 180, so it's half of pi, so it's gonna be pi over 2. So as you can see, each quarter, you see, each quarter is 90 degree or pi over 2. So you can say, okay, I have 1 here, and up to here I have 3. 1, 2, 3. So this is gonna be 3 pi over 2. See? So and you need to remember them. So please remember that 360 is 2 pi, 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, because we are gonna often use them, so it's good if you remember them. Now let's do an example. Find the radian measure of 1/3 of full rotation. 1/3 of a full rotation. Okay, so if it is 1/3 of a full rotation, I'm gonna just write it down. It's example 5. Example 5. It says 1/3 of full rotation. So what does it mean in terms of degree? It's gonna be 1/3 of 360 degree. I mean, this is degree, right? So now, what is in terms of radians? It's gonna be 1/3 of 360 degree is 2 pi radians, right? So it's gonna be 1/3 of 2 pi. So it's gonna be 2 pi divided by 3, right? 2 pi divided by 3. And you know, here is a way to convert between, I mean, if you want, you can use these formulas that gives you a way to convert, but I don't know, I can draw a circle and convert them. You can see whichever is fine with you. If you want to memorize the formula, you can use this formula for conversion, or you can just draw a circle or something like this for yourself to come up with the conversion. For example, convert pi over 6 radians to degree. Okay, the question says convert. Example 6. So what does it mean? Pi over 6 is a measurement in radian. The question is, what is this in degrees? Find this in the measurement of degree. So pi over 6, where does it stand? Let me see. This is 0. This is pi over 2. This is pi. This is 3 pi over 2. And also this is 2 pi. So pi over 6 is gonna be here. It's like pi dividing by 6, right? Or in other words, look, first of all, it's smaller than pi over 2, so it's gonna be in the first quarter, right? But where is it exactly? How can you obtain it from pi over 2? Okay, so if you, for example, if you go halfway through, if you go halfway through, right? So I mean, if you go like this, and this will be the terminal line is the middle of the first quarter, so that's gonna be pi over 2 divided by 2, right? Pi over 2. So that's gonna be pi over 2 divided by 2, which is pi over 4. But that's not the question. The question is find pi over 6. So let me see. What is the value that if I divide by it, it gives me pi over 6? You see the question? How much should I divide? For how much should I do the division to get pi over 6? The answer is 3. If you divide pi over 2 by 3, you get pi over 6, right? So 1/3 of this, so just dividing by 3, that means 1/3 of the circle. So suppose this is 1/3, right? Divide the first quarter into 3 equal parts, then the first 1/3 here represent this angle. Because if you start from here and go up and stops here, that represent the angle of pi/6. Okay, so far I just draw pi/6 and I haven't done the measurement. But now that we know pi/6 is just pi/2, look, we just realized that pi/6 is just pi/2 divided by 3. I mean, you can think about it that way. You could also do other, you could also think in terms of other angle, but that's one way. We can say that, okay, pi/6 is pi/2 divided by 3. Now, in terms of degree, so we know that this is 90 degree, right? Pi/2 is the same as 90 degree. So that's the same of dividing 90 by 3. It's the 1/3 of the first quarter, which gives us 30 degree. So the answer is 30 degree. So you can say pi/6 or you can say 30 degree. How did I come up with this? I just try to drive pi/6 based on pi/2. How can I drive it from pi/2? And I observed that by dividing by 3. If you divide pi/2 by 3, you get pi/6. So what is pi/2? That's 90. So divide 90 by 3. Gives you the value in degree. That's the way I'm doing these problems. But if you don't like it, you can go the way that your textbook is explaining. Convert 15 degree to radians. Okay. 15 degree to radians. So the question is, you have 15 degree. What is this? What is this in radian? What is the measurement in radian? Okay, again, I'm gonna draw a circle. Where is 15? Let me first see 15 in the circle. 15. So this is 0 degree. This is 90 degree. You see, because now the measurement is given in degree, I plot the values in terms of degree. This is 180 degree. This is 270 degree and so on. So 15 is gonna be somewhere here, right? 15 is gonna be actually 15 is half of 13, right? 15, this is 15 degree. This angle is 50 degree. So from algebra, we know that 15 is just half of 30, right? 30 divided by 2. And we just calculated 30. What is 30 in radians? It's pi/6, right? Pi/6 is 30 degree. So pi/6 is 30 degrees. So I just substitute 30 by pi/6. So it's like dividing pi/6 by 2, which is pi/12. That's the answer. 15 degree is pi/12 in radian. How did I get that? Because in the previous question, we just calculated 30 degree, I saw the relationship between 30 and 15. 15 is half of 30. So just divide it by 2. What is 30 in radian? 30 is pi/6. So just divide that measurement by 2. So it's going to be pi/2. It's going to be pi/2. But again, your textbook gives you another way of conversion. If you like it, you can also use that. And there is an example here that says find an angle that is coterminal with 90 pi/4, and the angle is between 0 and 2 pi. Okay, so the question says, this is example 8. And the question is, Find the angle beta. Beta is coterminal. Beta is coterminal with what? 19 pi over 4. Okay, so that's the first piece of information. And also beta is between 0 and 2 pi. Beta, so it's, in other words, it's in the first rotation. So find an angle in the first rotation that is coterminal with 19 pi over 4. I just need to see where is 19 pi over 4. Okay, and I'm going to show you how I can find it. It's so easy. Look. If you just follow what I'm doing with these circles, you can easily deal with questions like this. 19 pi over 4 is the same as 19 times pi over 4, right? 19 pi over 4 is the same as not pi over 4 multiplied by 19, or doing pi over 4 19 times. Okay, now this is the circle. I'm going to draw pi over 4. So this is pi over 4. How do I know this is pi over 4? Because this is 0, this is pi over 2. Pi over 4 is exactly in the middle of these two. It's it's the middle of the first quarter, right? So that's pi over 4. Now, pay attention that when you draw the circle in this way, first of all, we are dividing this. First of all, I mean, before pi over 2, maybe before looking at pi over 4. First of all, pay attention that we divide it into 4 equal parts, right? The first quarter, second quarter, third quarter, fourth quarter, right? So first of all, there are same portions, right? Same portions. Each one is one fourth, 1 quarter of the circle. And then when you do pi over 4, what is pi over 4? It's half of the quarter, right? So like this is half of the quarter, and keep doing the same thing. So it means that divide each quarter in half. Okay, divide each quarter in the half. Okay, so the value of each one is gonna be the same, right? So this is gonna be pi over 4 or 45 degree. It doesn't matter. You can either say pi over 4 or 45 degree, whichever measurement that you are comfortable with. This is gonna be also pi over 4. This is gonna be pi over 4. They must be the same because we divided. Actually, we divided the circle into, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it's like dividing the circle into 8 equal pieces. Each piece contains the same proportion of the circle, so they have the same angle, which is pi over 4. So this is also pi over 4, this is also pi over 4, and so on. Pi over 4, 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 pi over 4. So why do I do that? Because when it says 19 pi over 4, it's like rotating around this circle 19 times for how much? For pi over 4. Okay, so this is, look, you start from here. This is gonna be 1. So I'm doing pi over 4. How many times? 19 times. So it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay. So it's like, what did I do? I started from the horizontal axis and I moved pi over 4 for how many times? 19 times. So that's gonna be 19 pi over 4. So this line, what is this line? The line that is in the middle of second quarter, the line that cuts the second quarter in half, that is the terminal point. Are we good? So far, I just showed you this angle, 90 pi over 4 in the circle. That's all. Now, what does this question ask for? This question asks for angle beta. Beta is just in the first rotation, because pay attention that in order to draw 90 pi over 4, how many full rotation did I do? I did 1, 2, 3. So I did full 2 rotation, and then I came halfway through in the third rotation until I reached 19 pi over 4. But beta is between 0 and pi, which means that it is in the first rotation. It is in 1 rotation. We should not go beyond the 1 rotation. So while we are doing the first rotation around the circle, find an angle that stands at the same place. So I'm going to start from here, and I'm going to go around the circle and just stop at the same terminal side. So that's beta. This is beta. How did I came up with beta? We start with the same horizontal axis. We move around circle, and we just stop at the same stop point, same terminal point as 90 pi over 4. Now the question is, what is beta? What is the value of beta? Okay, let me see. How much did I move? I moved in terms of pi over 4. How many pi over 4 did I move? Look, we did 1, 2, 3. See that? So 1 pi over 4, 2 pi over 4, 3 pi over 4. So this is 3 pi over 4. So these two angles, 19 pi over 4 and 3 pi over 4, these two are coterminal, which means that they stop at the same place. But what's the difference? 3 pi over 4 is in the first rotation. So it's the first time that we are rotating around the circle. But 90 pi over 4 is the same location, but it's after 2 complete rotation. So while we are doing the third rotation around the circle. So you see, I mean, maybe they look like the same place, which is fine. They look like the same place. It's a matter of how many times, in which round, in which rotation you get that. If you're in the first rotation, that line represents 3 pi over 4. If you're in a second rotation, that's going to give you another angle. And if you are in a third one, so you see what I mean? So we answered the question. Again, your textbook solve the problem more algebraically, but basically when I do these chapters, I like graphing, and I teach trigonometric like this. I always draw a circle, I always draw angle, and I try to see it, because I believe that if you have a visual perspective of what's going on, then you can write your work. But if you just see something like this that is just pure algebra, then it may be a little hard or a little more time consuming to get a sense of what does each one represent. So that's my way. I recommend using circles and drawing in order to better understand these concepts. And okay. Area of a sector. So the sector is this cut. So for example, you cut a part of the circle. That's called a sector. And then here we are looking at the area of a sector of a circle with radius r that is determined by theta. it is half of theta r square. No, because the area is pi r square, right? The area, I'm sorry, I think somewhere in my note I said area. So far, we just talked about circumference. So when you have, maybe I just put a note that. So if you're talking about circumference of circle, that is 2 pi r, in which r is radius. If you're talking about area of circle, that has a formula of pi r square. I'm sorry, I think somewhere in my lesson, instead of, so far, in every example, we dealt with circumference. I think sometimes accidentally, instead of circumference, I said area, but we haven't talked about area. Now is the time that we want to talk about area. So we know that area of a circle is pi r square, right? And so in terms of this discussion, so when we have a circle, right, the area, maybe I use it here. Look, when you have a circle, right, the area is pi r square, in which r is just the radius, right? R is just the radius of the circle. So here we are talking about a sector, like here, right? So we are talking about a portion of that area. So maybe I show you something here to get to that point. So when you do a full rotation, the angle is, what is the angle? Look, we are doing a full rotation. The angle is 2 pi, right? The angle is 2 pi. And so when you do a full rotation, the angle is 2 pi, the area is pi over r squared. So if you do, instead of a full rotation, you just do a portion of, let me show you what I mean. I want to explain you what your textbook is saying here. So for example, in your textbook, it says, suppose you have this sector and you want to know what is this, right? So we know that the area of a circle is can be calculated by pi r square, pi radius square. But what about this one? Okay, so this one also has, we know the radius, right? We know the radius and we know the angle. Suppose the angle is theta, right? So now what is the area of this green portion, which is called sector? So we can derive it because look, when theta was 2 pi, right? The area is pi r squared. So from here, I can look from here, solve it for pi. So theta over 2 is gonna be pi, right? And then substitute here, it's gonna be theta over 2 r squared. Yeah, I derived it. You see? So we know that the area of a circumference is pi r squared, right? Why is it pi r squared? Because when you do a full rotation, the angle is 2 pi. So from here, we can derive that, okay, so the angle divided by 2 times by radius square gives us actually the area of such things. So in this case, my angle is not 2 pi, it's smaller than 2 pi, it's theta. How can I find the area of the green part? The area here is whatever is the angle divided by 2 times r square. That's exactly the formula here. Area of a sector is half of the angle times radius square. For example, suppose it says an automatic lawn. Okay. So this whole thing gives us a rotation of 30 degrees. What is the area of a sector that you can see in this picture? So the angle is 30. The radius is 20, right? So that means the area is half of, by the way, the angle must be in terms of pi, in terms of radians. So first of all, 30 degree is pi over 6. We already saw that in previous example. So it's going to be half of pi over 6 times radius square. You see, half of the angle times r square. So it's going to be half of angle is pi over 6 times radius, which is 20 square, which gives you the area of a sector. I think that's enough. Yeah, I think that's enough for now. Based on what we need, need from angles for the following sections, I think enough. Basically, you just need to make sure you know how to place angles in a circle. What is the positive, how to draw when the angle is positive and negative, and measurements. Express the angle in degrees and radians and convert. So when I say pi over 6, you should be able to say it's 30 degrees. When we say 60 degrees, you should be able to convert it to pi over 3, okay? So you need to be able to do the conversion. But in the following section, you will see how we use these to introduce trig functions. Okay, that's all for now. I'll see you in the next video.